Welcome to this video. In this video, I want to discuss about the differential equation. This is part 1. In this part, we want to discuss about the order and degree. Actually, we wants to follow up the mathematical methods by H.K.Dass. This is will be helpful for BSc Physics honor student and also different examination like IIT JAM, GST, SET, CSR, NET, TIFR, GATE. This will be helpful for all of them. So let's start. Some at very beginning, so we just define some basic term. What do you mean by differential equation? The equation involved is differential coefficient like dy dx, d2y dx square, del y del x. This type of equation is called differential equation where these term are included. The equation in which these differential parts like dy dx, del y dx are included. This is called differential equation. What do you mean by partial differential equation? A differential equation involving more than one independent variable in and that are represented by del. Okay, here the phi is function of x, y, z. This is y, this is z. Okay, and ordinary differential equation with the single independent variable when they are written here like d2y dx square dy dx. Here the y is a function of only x. That's why this is a ordinary differential equation and this is a partial differential equation. And what do you mean linear operator? Linear operator, the basic funda of the linear operator is the if we add and then operate, and if we operate then add, this will be the same. So first order derivative, that is the first ddx, if we derivative, then we will get this equation. So this is a linear operator. And second derivative also a linear operator. If you take their combination, this is also a linear operator. So this can be written as this and at a summation form, right? What do you mean by homogeneous and inhomogeneous? Homogeneous ordinary differential equation means depend variable occur at the same power. Here you can see the power is x, y, that is 1, 1, 2, this is 2, this is 2. All our elements are power with same. That's why this is a homogeneous equation. Here also the power will be 1, 1 cancel out, power will be 0 and this power also is 0. So this is a homogeneous equation and this is written in the general form like that. Inhomogeneous equation, the opposite of the homogeneous equation where the power is not same. And this is your homework, do yourself. That is the time dependence origin equation. Is this homogeneous or not homogeneous? Next is if c1 y1 c2 y2 are the two solution, then this is a also a solution. This is like a superposition theorem of wave of t electrodynamics and quantum mechanics. Nonlinear differential equation where we cannot like this operator, we cannot write this operator where this operation are follow, this operation are follow is called linear. If not follow, this is the non-linear differential equation. Okay, and next is order and degree. This is the our motto to find order and degree of any differential equation. Order is the highest derivable appearing therein. If we consider this is a differential equation d2y dx square plus 5 dy dx plus y equals to 0. Here maximum derivative is 2. This is the order will be 2, and the degree is the power of the highest order. So degree will be, here the power of the highest order is 1, so this will be 1. Okay, if there is differential equation like that, that is whole square plus dy dx equals to y to the power 2/3. Okay, we need to rationalize this equation, so we need to cube of this equation, that is d2y dx square plus dy dx, there is whole square, that into whole cube is equals to y square. Okay, so these 2 and 3 will multiply, so order will be 2, maximum derivative 2, and the degree will be 2 into 3, that is 6. I think clear. Now Formation of differential equation. How we can form a differential equation? Suppose you have a equation, a straight line y equal to mx plus c. This is a equation of a straight line, you know very well. This is a equation of straight line. Here two constant, m is a constant, another constant is c. So maximum derivative can be possible 2, that is order will be 2. There is a constant as 2, so you can derivative maximum 2. So first derivative, if we first derivative dy dx, this gives you m, and if you take second derivative d2y dx square, this gives you 0. This is the differential equation of this. If we take another equations of suppose x square plus y square equal to a square, this is the equation of circle. There is one variable, so maximum you can derivative 1. So if you derivative with respect to x, this gives you 2x plus 2y dy dx is equals to 0. Just can written in the uh, simply from, that is dy dx will be 0. This is the differential equation. Suppose you have y is equals to a e to the power mx. There is two variable, so dy dx you gives a e to the power mx with m. So this is nothing but y, so this is my. So you can write 1 by y dy dx is equals to m. If you derivative this, so you get 1 by y square, sorry, at first we derivative this one, so 1 by y d2y dx square, and this is minus 1 by y square, and this becomes dy dx, and they are 1, so whole square, this will become 0. So if you multiply y square, this is y d2y dx square minus dy dx whole square will be 0. This is the differential equation. I think clear. If there is the number of constant gives you the maximum allow to the derivative. Number of constant is the maximum derivative means the power will be the that means the order, that is the order derivative. Clear. I just follow up the mathematical methods by H.K.Dass, and this is the exercise of this book. Clear. Exercise 3.1, where says write down the order and the degree of the following differential equation. So first one, you can see here the maximum derivative is 2, so order will be 2, order and degree. So order will be 2, and degree is the power is 1, so degree will be 1. Number 2, here we need to rationalize that we need to square this, so 1 plus for this, so 1 plus dy dx whole square, that into whole cube is equals to d2y dx square, that into whole square. So the order will be 2, and maximum is the degree will be 2. In this equation you can say the maximum derivative is second, so order will be 2 and the power is 3, so degree will be 3. I think clear. Next, give an example of each of the following differential equation. Linear differential equation of second order first degree. Second order first degree. So linear differential equation second order first degree. So second order means this is, and first degree, so like that dy dx plus y equals to 0. Number 1. Number 2, a non-linear differential equation second order second degree. Non-linear means you need to rationalize, so second order second degree d2y dx square whole square plus dy dx or y whole to the power 2 third, this is the non-linear, into dy dx square, like that. Number 3, a second order third degree third degree second order d2y dx square third degree whole cube plus like that x cube x square dy dx plus y equal to 0, like that. I think clear. Next question says Define an example order and degree, which we already discussed. You can solve this one. Next question is obtain differential equation of which y square equal to 4a into this is a solution. So we need to eliminate this a, right? We need to eliminate this a to get the differential equation. So here y square equal to 4ax plus 4a square, just separate out, right? So we can derivative maximum one time we can derivative this one. So just derivative 2y dy dx with respect to x, you will get 4a and this will be 0, right? So what will be the value of 4a? You can see here, if you just multiply with respect to x, we need to eliminate the a, right? So if you square this one, actually we need to eliminate this for a, just eliminate this one. So this is y dy dx equals to 2a. So if you square, that is y square dy dx whole square equals to 4x square, 4a square, 4a square, 4a square, 4a square. What is the value of 4 square? 4 square. What is the value of 4 square? What is the value of 4 square? 4 square, 4 square, 4 square. So if we multiply 2ay dy dx equals to 4 square, 4 square means 4ax. Okay, we can solve in another way. That is, if we multiply with respect to, that is can be written as y dy dx is equals to 2a, right? If we multiply with respect to x, that is xy dy dx and multiply 2 such that is become 4ax. Okay, so if we add these two, we can write on y square. So y square dy dx whole square plus 2xy dy dx. So you will get 4a square plus 4ax, and this is nothing but y square. So you can write y square dy dx whole square plus 2xy dy dx minus y square is equals to 0. I think clear. Next, obtain the differential equation associated with the primitive this. This is the equation we need to solve into change into differential equation. Here two variable, two constant, so we can derivative maximum two times. So ax square plus by square equals to 1. So if we take a plus b y square by x square equals to 1 by x square. Just derivative with respect to a, it will be 0. This is b. With respect to x, this is 2 by x cube y square and 1 by x square 2y dy dx equals to minus 2 by x cube. Just take b here and x cube, so x cube by 2 minus 2 by x cube y square plus 1 by x square 2y dy dx is equals to 1 by b. Just multiply to simplify, that is y square minus 2 to cancel out x cube, so xy dy dx equals to 1 by b. Now if we derivative with respect to x, this is y 2y dy dx with respect to x, that is y dy dx with respect to that is x dy dx and dy dx. So this become whole square minus xy d2y dx square, this becomes 0. So if you put a multiply with the minus, so this is xy d2y dx square, this term, and this is plus x dy dx whole square, and this gives you minus y dy dx. We multiply with respect to minus. I think clear. Next, find the differential equation corresponding this equation. So here also two constant, so maximum we can derivative two times, that is a e to the power 3x plus b e to the power x. So you can write, if we multiply with respect to e to the power minus x, that is e to the power minus x y equals to a e to the power 2x plus b. If you derivative, then this gives you minus e to the power minus x y plus e to the power minus x dy dx, and this is a 2 e to the power 2x, and derivative of b will be 0. If we multiply e to the power minus 2x, so this become e to the power minus 3x y plus e to the power minus 3x dy dx equals to 2a. Just derivative with respect to x, this become plus 3 e to the power minus 3x minus e to the power minus 3x dy dx, and this gives you minus 3 e to the power minus 3x dy dx, and derivative of this plus e to the power minus 3x d2y dx square. Derivative will be with respect to x, and this becomes 0. So this can be written as e to the power minus, if we multiply e to the power minus 3x, so this will be cancelled out, so e to the power y dx square, and these two terms are added, that is minus 4 dy dx, and this is 3 y, there is a y missing of y, so this is 0. Clear. And next one is y is equals to a e to the power x plus b cos x. Okay, so if we multiply with respect to e to the power just derivative at first, in just derivative, sorry, e to the power minus x, e to the power minus x y equals to a plus b cos x e to the power minus x. Now if you derivative, that is minus e to the power minus x y and plus e to the power minus x dy dx, derivative of this is 0. b, derivative of cos x is minus sin x e to the power minus x, derivative of this is minus cos x e to the power minus x. So if you take e to the power minus x common, this will cancel out, so minus y plus dy dx is equals to minus b sin x plus cos x. Okay, sin x plus cos x, sin x plus cos x, sin x plus cos x, b minus b sin x minus b cos x, minus b sin x minus b cos x, minus b sin x minus b cos x, minus b sin x minus b cos x. Okay. Now if you wants to derivative, actually if I wants to write this as dy dx minus b, actually if you derivative, what will we get? That is minus dy dx, and this is d2y dx square, and it is minus b cos x minus sin x, right? So this is the minus b minus v minus b sin x plus cos x, this becomes this term, and uh, my there was a plus sin x, you write, so there is 2b sin x, right? 2b sin x. uh, if you write this is plus, so this becomes b cos x minus sin x, so 2b cos x, 2b cos x. This is make difficult. We can, sorry, we can process in another way. Suppose, sorry, suppose you make first at derivative, simply derivative, you must derivative at first, sorry, just derivative. So what we get, dy dx will be a e to the power x minus b sin x. Then if you derivative again, d2y dx square, this is a e to the power x plus b cos x minus b cos x. So if you write them into that manner, that is a e to the power x minus minus b sin x in terms of 4 minus 3 a e to the power x plus b cos x can be written as this. No, this is not possible. This is not possible. Mm, I think there is some wrong. Uh, Sorry, this is make very clumsy. E to the power minus x y equal to a plus b to the power minus x cos x. Sorry, we will solve it later. We will be solve it later. This becomes, actually, if this is a answer, so we need to satisfy this equation, but this is not satisfy. I think this is another process. So e to the power minus x y plus e to the power minus x dy dx equals to b to the power minus x cos x and minus b to the power minus x sin x. So if we multiply to the power minus x, so minus y plus dy dx equals to minus b cos x minus b sin x. Okay, so if you derivative again, that is dy dx plus d2y dx square minus plus b sin x, and this is you can write here minus b cos x, that is the minus b cos x is a to the power x minus y minus b sin x. Okay, we can write this. So minus y cancel out, so dy dx is nothing but a to the power x minus b sin x, a to the power x minus b sin x. So that is, so if you multiply to the power minus x, you will be get e to the power minus x dy dx equals to a b to the power minus x sin x. So this become minus e to the power minus x dy dx plus e to the power minus x d2y dx square, and this is 0 minus plus e to the power minus x sin x and minus b to the power minus x cos x. E to the power minus x will be cancel out, so minus dy dx plus d2y dx square equals to b sin x minus b cos x. B sin x minus b cos x. Okay. We need to solve in later. Okay. Go to the next question. By the elimination of AB, find the differential equation which y equals to this. So y is equals to e to the power x a cos x plus b sin x. So if you derivative with respect to y, that is dy dx gives you e to the power x a cos x. I just take it at the left hand side, e to the power minus x y equal to a cos x plus b sin x. Now if we derivative, so this become minus e to the power minus x y plus e to the power minus x dy dx equals to minus a sin x plus b cos x. Again we differentiate, so this becomes e to the power minus x y minus e to the power minus x dy dx. This is minus e to the power minus x dy dx plus e to the power minus x d2y dx square, and this gives you minus a cos x minus b sin x. So this is nothing but e to the power minus y e to the power minus x y. So e to the power minus x are cancel out, you will get y minus 2 dy dx plus d2y dx square equals to minus y. So this gives you d2y dx square minus 2 dy dx, and this y in the left hand side gives you 2y equals to 0. Go to the next one. The differential equation whose solution equals to this. So this is the solution, y equal to a cos x plus 3. Okay. So if you write dy dx, what will you get? Minus a sin x plus 3. So what is the value of a? You can write here y by cos x plus 3. Just put here a equals to y by cos x plus 3, and this is the sin x plus 3. So this will be tan minus y tan x plus 3. So dy dx will be minus y tan x plus 3. Next question. Show that this set from a basic differential equation. So this is a set x and 1 by x. We can take a x plus 1 by x. Okay. B 1 by x. B into 1 by x. We need to eliminate a and b. At first we can multiply with this with x. So xy equals to a x square plus b. If we derivative with respect to x, you will get x y prime plus y equals to 2ax. Okay, and just divided by x, you will get y prime plus 1 by x y equals to 2a. Now if you derivative with respect to x, this is y double prime minus 1 by x square y plus 1 by x y prime equals to 0. If we multiply with respect to x square y double prime minus y plus x y prime equals to 0. Or you can say this is x square y double prime plus x y prime minus y is equals to 0. This is the differential equation. Obtain a particular solution when this is d. So y is equals to ax plus b by x. So put the value y1, that is equals to 1. So 1 equals to a plus b, and another one dy dx. So y prime is nothing but a minus b by x square. So put here y prime equal to 2, so 2 equals to a minus b. So put here 1 equals to a plus b. So 3 equals to 2a. So a equals to 3 by 2, and put the a value anywhere. You will get b equals to 1 minus a, that is 1 minus 3 by 2, that is minus half. So the solution will be y equal to ax. A is 3 by 2 x, and b by x, b is minus half x. So this is the solution. Clear? Next, choose the correct answer. Okay, y equal to cx minus c square. Y is equals to cx minus c square is the general solution of the differential equation. So there is one variable. So if you derivative y prime, you get c, only c. So you need to find out c here. um, if you square this y prime square, this is c square. What is the value of c square? If we multiply this with respect to x, that is y x prime equal to cx. If you add these two, no, subtract. So if x y prime minus y prime square, x y prime minus y prime square gives you cx minus c square. Cx minus c square is nothing but y. So you can write y prime square minus x y prime plus y equals to 0. Is there any equation? Yes. So option number A is the correct answer. Option number I 1, answer is 1 is the correct answer. Go to the next one. Differential equation governing y x equal to this, where c is the arbitrary constant. So the differential equation, so y is equals to root over 5x plus c. So we square y square equal to 5x plus c. Differentiate, that is 2y dy dx, or you can write y prime equals to 5. So you can write as the y prime 2y prime, or y prime equals to 5 by 2. So option number 4 is the correct answer. Option number 4 is the correct answer. Go to the next question. The differential equation having a basis of the solution as such cos hyperbolic 6s and sin hyperbolic 6s is basis of the its solution. So y can be written as a cos hyperbolic 6x plus b sin hyperbolic 6x. So if you derivative, so this becomes 6a cos hyperbolic 6x, derivative is sin hyperbolic. Similarly this is 6b cos hyperbolic. So if you derivative again, this gives you a 6 square, a cos hyperbolic 6x, and this is 6 square, b sin hyperbolic 6x. So take 6 square as a common, the remaining part will be 6. So y double prime minus 36 y equals to 0. So answer number 3 is the correct answer of this question. Next, if the function 1 and e to the power minus 1 is the fundamental system solution differential equation, then what is the value of a and b? So one solution is 1 and another solution is minus of it, they are minus 3x. So you can write a minus b by e to the power 3x. So if you derivative y prime equals to this is can be written, this is easiest process. So minus plus 3b e to the power minus 3x. Okay, so e to the power 3x y prime equals to 3b. So if you derivative, this will e to the power 3x y double prime plus 3 e to the power 3x y prime equals to 0. So y double prime plus 3y prime is equals to 0. So if we compare this given equation, that is y prime plus ay prime plus by equals to 0, you can see here a equals to 3, sorry, a equals to 3 and b is equals to 0. A equals to 3, b equals to 0. The option number A is the correct answer. Option number 1 is the correct answer. Go to the next one. The differential equation is y to the power 1 by 3. So d d actually 1 by 3 means this is non-linear, so there will be two options. So dx dy whole square minus x will be minus 5 y to the power 1 by 3. So if you whole cube both side, so this becomes dx dy whole square minus x whole cube is equals to minus 5qy. Okay, so the order will be first order, and degree will be 6. Degree will be 6. Order is first order. Order is first order and degree will be 3 into 2 6. Degree will be 6. This is a non-linear and the order will be 1 and degree will be 6. I think clear, and one solution does not obtain in this video. I will be supplying the description or the comment in the PDF from. Okay, so this is all about me, and this is my contact details. You can contact with me any physics related question, and this is my YouTube channel details. You go through this channel, you can get the videos which already uploaded, and I have a series solution of the vector analysis by Emma Spiegel book. You can also watch this series of solution. And if you new in this channel, subscribe this channel, share this video to your friends so that he also or she also get benefit from this video. Press the bell icon to get the notification of upcoming video. Take care, we'll meet in the next video as soon as possible. Thank you.